Yeah, first.
Yeah. Oh,
Your statement is over there.
First, I need to respond that lady's question because I didn't hear very clearly at that time. So as for the tangential traction pressure distribution, we just use the Carter series to get a rough estimation. Rough estimation. Otherwise, it seems that we don't have any other ways to do this prediction, or if you don't use the multi-body dynamic softwares. So we just still use the Carter series. Also, our previous work used the Carter series to predict that. That's my answer.
Thank you for the answer, but I would like to introduce your statement.
Yes, from my work, so we just simply got this conclusions about the hybrid UTech toys with the low carbon contact has the best racing performance. And for our next plan, we may consider the racing performance and under the one rail and wheel profiles, and also the racing performance of the different flashbar welding wheels. Yes.
Thank you. Dr. Kato, please.
Sorry. Yeah. So as I explained my presentation, so this technique which we propose is used for the design of the wheel quality, especially internal defects. So we have confidence of our product, quality of product. So we hope in the future this technique will be used for prevention of the rolling contact fatigue damage.
Thank you. Mr. Liu, please introduce yourself.
Okay. My work is a lot of compared measurement and some simulation result. And the wheel tread spooling is very difficult, and in a fixed line, and its running speed and tracking weight is the same. And in this condition, some locomotive suffers serious spooling, and from the compared result and wheel sliding, idling, and small curves may promote the initiation of the transverse cracks, and especially around the wheel tread center. And these cracks was further propagates into the material and shorten the service life of the wheels. And how to decrease the wheel tread spooling is also in study, and we hope to find some effective measures to increase the service life of wheels. Okay.
Dr. Smith, please.
I think mine's probably self-explanatory, increasing rail life and heavy haul applications, but I think as a company we very much believe working with operators, if we do have a new product and working together to be able to prove the benefits that we say it will do. And that's why we do go out on track and do trial sites with customers. So when we work together and we come back with the results together so they know what we're saying is true.
Thank you. So now if anyone has questions to both or no, to four speakers, please ask. We have one.
It's not a question, but my desire to Mr. Kato. In Japan, you know, the axial load is not so heavy, and the train speed becomes faster and faster. So the most important problem is surface coated crack rather than subsurface crack. So I want you to study or research about surface cracks. And is there any idea to apply your technique to the surface crack?
Yes, actually, we have developed a simulation model can be considered water penetration into the crack. So I think this is useful to evaluate R-shaped life initiating the surface, at the surface. Yeah,
Thank you very much.
Do you want to comment on this question, other speakers? What model can we use for such studies? Surface crack studies. Probably we can go to the next question. There is one.
So my question is for Dr. Smith. So for the HP335 rail, you mentioned that this is something that's being tried in Britain right now. Is there any desire to introduce this to North American heavy axle load traffic, being 35 ton per axle? It's a little bit heavier. How would that still perform in North America?
So no, because we have a superior product HP, which is MHH, which is harder again, which is a heat-treated product, which is better for heavier axle loads.
And my other question on the same steel, when you gave that presentation yesterday at ICRI, you did mention that the hardness was through the head of the rail. Can you talk about that a little bit?
Because it's an as-roll product, with heat treatment, depending on the heat treatment process, the hardness will vary out through the head to decreasing down, but obviously because HP335 is an as-roll product, it's the same hardness throughout the rail.
Okay, and a third question, last one. So looking at the microstructure, the difference between the 260 and the 335 seems to be that you have a super prolific structure, right? How is your grain size in that microstructure?
I don't have the answer. I can find the answer, but yeah, sorry, that's a bit out of my remit.
Thank you.
No.
Do you have other questions? In this case, probably we still have 6 minutes, and I would like ask Dr. Kata to comment a little bit on his methodology, or probably I will provide some insight. So my understanding was that this methodology is used just to verify your numerical model, yeah? What you produced, all this sample, and after that you introduce an artificial hole in your sample, and after that you did finite element analysis. So the sample was done for what purposes?
Sorry.
Sample, your design sample was done for what purposes? What is final destination of your
Sample specimen?
Yeah, you introduced this one. It was previous question about that you have a sample
Yeah.
and you have artificial hole inside of the sample. What is real purpose of this sample? Just to verify your methodology, or it's some other applications? Or
Sorry, maybe I cannot understand your question. So, the specimen
specimen.
was taken from the actual wheel near the turret, and then we introduced a small hole at the surface of the specimen. So,
Yeah, but for example, if you take spaceman and you take, you made some modification of actual wheel because you made some modification of your spaceman, actual spaceman from the wheel, and you introduce it whole.
Yes.
So what is the main reason for this? So, do you have any other area of applications, or
Yeah, mainly we would like to know that fatigue limit, whether fatigue limit change, decrease with the existence of some defects. So, yeah, so
it's more related to fatigue studies, yeah?
yeah.
And how about rail? If you are doing similar job, what you will do?
Can't hear properly, sorry.
How about rail? If you are doing similar job, what are you going to do? How you are going to do such stuff?
Sorry.
Anyway, any other questions? Probably it's time to finish it. We still have one. Probably last one for today.
Okay. Just continuing what you were discussing about introducing the whole, I just wanted a little bit more maybe information about that. What kind of control did you use? Was it angular displacement control or a torque control on while you were testing the specimens after introducing the whole?
Yeah. Sorry.
On your fatigue testing
Yes.
for torsion shear stress,
Yes.
was it angular displacement controlled or it was torque controlled?
Torque control.
Okay. So for the same torque, when you introduce a hole, your cross section is reducing?
No. Actually, the load with fatigue limit level, not there's no reduction.
Yeah, but when you introduce a hole, your effective cross section has changed
Effects.
of your element. So if you have torque control, are you applying like different level of localized shear there?
So you mean the area of cross section decrease
Right.
due to the
Due
crack?
to the defect itself. So
Yeah.
yes, there is like, so I'm just curious whether the shear stresses locally are also changing than what you would assume with a uniform cross section.
Actually, we evaluated only nominal stress, not true stress, so not considered.
Okay, thank you very much, all speakers. Yeah. And we can have a break. Thank you.